Hey guys, welcome to another video. So today we continue on with the probability topic doing random variables. So last lesson we did discrete random variables. So today we'll do continuous random variables. Now, if you haven't already done so, please subscribe to the channel, like the video, tell your friends. Everything's free, so I just thought I'd do a few videos on maths, put it up on the internet, put it up on YouTube for you guys. Yeah, tell your friends. So continuous random variables. Let's go there. So now, a lot of teachers obviously will do this as one of, if not the last topics in Year 12, right? So, and the reason why this part is split, well, the reason why you couldn't do this in Year 11 is largely because you need integration, right? So if you haven't done integration, go learn some integration first before you do this topic. Otherwise, it's actually a big showstopper. So now, last lesson, we said discrete random variables are variables that are countable. So like, for example, the number of students in a class or the number of car crashes, etc. Continuous random variables are variables that are, well, have infinite values. So for example, we use the example of the heights of people, because in real life, the heights of people are usually rounded, so they look the same. But in reality, if you go to the nth decimal place, they were a little bit different. So continuous random variables are usually modeled on a number plane, right? The function is modeled as a given graph, a function. So let's start there, right? So there's a few pieces of theory I like to do before I dive into past papers. So here we go, right? Let's really talk about the probability density function, right? Or the PDF, right? Let's call it a PDF. So unlike discrete random variables where all the information, all the probabilities are given to you in a table, right? Continuous random variables aren't. They're given to you in terms of the function. So for example, they basically say, here is, a number plane, right? And this graph here between the values of, well, let me give you between values. I'll go capital A and capital B, right? Yeah, that's my entire probability function, right? So they'll go, this guy is a function, let's call it y equals to fx. Yeah, where I know that the PDF basically says the sum of all, the total probability rule, right, is basically from capital A to capital B of the function dx, that equals to 1. Yep, similar to the total probability rule we use for discrete random variable, this guy is the PDF, right? Now, within the boundaries of A and B, let's go from little a to little b, right? So little a to little b. If I wanted the probabilities for all these components, right? All the area in between here, then I know that probability, well, maybe I'll just use P, right? That A is less than or equal to X less than or equal to B would equal to that fx dx. Now, this formula is very useful for finding things in continuous random variables such as median or interquartile range, etc. I'll go there in a second, but for now, guys, you should know this. If you've done this, treat this lesson as revision. I'm hoping that you've seen some of these formulas before at school, but I thought I'd throw it in front of you as a simple diagram. Now, in this topic, there is always a comparison between a PDF, a probability density function, and a cumulative distribution function, right? So a CDF, so cumulative distribution function. So a CDF, which the way that I always describe it to my students, it's like the bigger brother of a PDF. So if PDF is like the derivative, then CDF is like the integral, right? So, and the analogy that is always good to sort of see side by side is, do you remember like back in stats when we used to have a histogram that sort of looked like this, right? Let's go, yeah. So that's a frequency histogram, right? And then when we did a cumulative frequency histogram, it just stacked up like this, right? So I'm just gonna no scale, yeah, and it just goes up and up and up. So this is a cumulative frequency histogram, right? So the analogy is very strong. So for example, if I gave you, oops, I don't have enough vertical space. Let me just move this up. So if I gave you a PDF, right, function that looks like this, right? So this is y equals to fx. Then, so this is a probability density function. I can sketch, right, based on this, I can sketch a CDF function. Now, you can see, let's pretend that the first value started at 0, and I can terminate the value at, well, let's call it capital A and capital B, just like I did upstairs, right? And capital A, it always starts at 0 there. And capital B, now, the total probability rule, right, what the cumulative distribution represents is, if I add up each individual, right, and these guys add up to total probability, and I know for sure it always terminates at 1, right? And this graph here basically represents the growth. So if it grows slower, so it probably looks like that, right? But overall, it should hit 1 by the time B hits, right? So this guy here is y equals to capital Fx. Yeah, cumulative frequency. Now, the relationship in terms of formula between the cumulative, right, and the PDF, right? So this is CDF. Is that for a CDF, yeah, where Fx capitalized, you basically just integrate it from whatever boundary. Now, let's use maybe negative infinity to infinity, right, to be more exact, yeah, of the PDF. Now, you can't use x here, right, because there's already an x. Sorry, I did that wrong, because if the top was, if this is fx, then I'll go from negative x all the way to x. Use a different variable, ft, right? That there. Now, let me explain what that means, right? So basically, this is saying, right, if I wanted to add up all the probabilities from the starting point to whatever value x there, right? Yeah, this guy here would represent f of x. Yeah, and where that is, where the sum of all this area here is basically x there, whatever value that is there, right? Yeah, so this guy here would be the capital F of x on my diagram, right? Or maybe I'll use t. Yeah, better. So when this is t, t is better because then I already use x there. Yeah. So that's the relationship between the PDF and the CDF, where one is the integral of the other. Yeah, from negative infinity or negative lowest value to whatever x value that you want to go to. Yeah. All right, guys. A few more formulae before I guess we move on. I really want to touch on, the things that you can find like mean, variance, and all that as well, just to present you with the formulas before I dive right into the actual question. So maybe I'll see if I can fit it all on the page, right? Number 3. Oh, got my slash. Now the mean and the variance, very similar, right? Very similar beast to what we did before. So if I said to you the mean, no, that's expected value, right? Same thing, equals to. Now, before, for discrete random variables, we take the sum and then we go x times the probability. This is similar because the integral sign is effectively the sum, right? And then we go x times probability, which is fx, right? Dx, and this is across all values. Yeah. So maybe in this formula here from A to B, more specifically, also more generally, negative infinity to infinity is probably a bit more exact, right? Probably more exact. So that's expected value or the mean. Guys, we know variance. Yeah, we know the formula for variance actually varies, actually the same, right? var of x equals to expected second moment, right? Expected value x squared minus the expected value squared, right? Exactly the same. Where we know, right, the top one here is mu, and mu is exactly the same as this guy here, right? While this guy here, essentially the same as what we did before, right? When it was discrete, we did the sum of x squared times px, but for integration will be this guy, x squared times its probability, which is fx, right? Same thing there. Now, I want to talk about median, right? Median, lower quartile, which they call Q1, Q2, also Q3, and IQR to quartile range, right? They also use this concept. So just to be absolutely clear, right? When we sort of plot probability here, I can have a probability of 0, right? I can probability 1, 0.5 there, right? Obviously 0.75 here, 0.25 here, right? Now, I know that this guy here represents the lower quartile. This guy here represents the upper quartile, and 50 percentile is the median, right? Yeah, and to find all that using the formulas that we know, for example, I'll deal with the median, right? You basically go, you set from negative infinity to whatever x value you want of ft dt, and you set that equal to 50%. And so what you do, you integrate and then you solve for x, right? So if I wanted to find the lower quartile, I'll do exactly the same, set it to 0.25, upper quartile, set it to 0.75, right? And interquartile range, you just take the difference of Q3 minus Q1. So we'll be doing a question that basically touches on this later. And guys, final note. Now, am I sort of squashing in? Oh, got a little bit of space. Just gonna shift that over a bit. So I can write and move this guy maybe over a bit. You know what? Move this guy down maybe. Perfect. Final piece, like we done mean, median, mode, right? So for the mode, right, it's all about, because what is the mode? So if I gave you, right, a probability density function, right, that looks like this. To find the mode, I basically need the highest point here, right? That's the mode there, right? That's the mode there. So to find the mode, it's all about stationary points, right? This guy here, so the mode, there's no formula per se, but we basically find the max stationary point, right? And generally speaking, we use calculus to do it, right? Yeah, find the derivative and set it to 0 and solve. Guys, that was a lot of theory, right? This is probably the heaviest theory that I've given in all my videos, but there it is. Let's do some questions. That's enough for me talking about theory, right? Let's see how many we can get through. So, Gosford 2020. Here it is, pretty straightforward question where they basically give you, now, what did they give you, by the way? Just to be clear, they gave you a PDF, right? Yeah, gave you a PDF, so the total probability rule kicks in, right? Show that the constants are, that's probably using the total probability rule, so show that the constants are, and then define the CDF, so find the CDF, so we're going to integrate. So very straightforward, we're going to do marks. This was the first year of the new syllabus in New South Wales, so that's probably why there's so many marks. I think the marks are going to fall over time as students find it more easier and easier. But for now, first one, they basically say, so the sum of all probabilities, right? So we know that from negative, if it's a PDF, right, then the integral from negative infinity to infinity of fx dx should total to 1, right? Pretty straightforward concept. So I'm just going to integrate this function here, right? This function here. So let's say I'll bring the constant outside. Now, my negative infinity to infinity is just basically my lowest and upper limit. So it's 1 and 4, right? Of x squared minus 2x plus 2dx. Should go 1. Very easy to integrate. Yeah. So x cubed 1, 3 minus x squared plus 2x, 4 and 1 equals to 1. Just a bit of algebra now, so sub in the 4 plus 2 times 4, sub in 1 minus 1 squared, oops, plus 2 times 1. And that should equal to 1. Yeah. Now, I believe if you do punch in calculator, unless I've done something wrong, if you punch this into your calculator, 12, is it? 12k, whoops, wrong color. 12k equals to 1. Well, I believe, I mean, that's what the question's asking you to do, so yeah, it has to be the 12. Right? And then for part B, all they're really asking you to do is to basically express a CDF. Now, one thing you need to know, right? Remember, for all CDFs, right? All CDFs always has to start at 0. Yeah, whatever starting point always has to start at 0, and it always ends, wherever it goes, always ends at 1. So when we define this, there's always going to be a piecemeal function where I go, it's 0 at the start, it's 1 at the end, and in the middle, it's just an integral, right? Just an integral. So let's see. So for part B, if I found k to be that, then I know that my fx, right, would equal to the integral from 1 to 4, right, of fx. So now I have 12, so I'll go 1 on 12, right? In fact, I've already integrated it here, right? Already. So what I'm going to do, I'm going to write it in anyway, right? Just so you know, this is how we were to do it if we had to, right? 2x plus 2 dx, right? That's what I would do now. So if I integrate, I'm just going to multiply 1/12 by this. So yeah, so I'll show you what I'm trying to say. I take this and, sorry, I highlight the wrong thing. I take this and replace that with the integral there, and then I multiply by 1/12. So this should be, now, I'll be smart because I'll write it down here and I'll explain why. So 1/12 times that is x cubed on 36 minus x squared on 12 plus 1/12 times 2x is x on 6, right? Plus c. Yeah. Now, oh, sorry, not plus c. So I've got the limits. So I've got limits of 4, oops. Oh, sorry, no, that's not what I do at all. My bad. It's not 1 to that, it's 1 to, this is bad. Right, this is really bad. I don't mean to do this. So all these guys here should be t's, right? Do you remember, right? When you do this, yeah, there's a little t there, t there, t there. And so when you do this, and I sub x in, and then I gotta take that and I minus when I sub 1 in, right? So same deal. So it'd be 1 on 36 minus 1 on 12 plus 1 on 6. Now, you just punch this in the calculator. I think it's, I'm hoping there's like a quarter. Let's have a look. So just make sure 1 on 36 minus 1 on 12 plus 1 on 6, 1 on 9. Did I integrate that right? Yeah, looks like 1 on 9. Oh yeah, it is 1 on 9. I'm just reading that wrong. So final answer, right? So that's my integral. 36 minus x squared on 12, perfect. X on 6 minus 1/9. Yep. Looked like a quarter. It's actually 1/9. Now, if that's your answer, right? And just to be clear, where did that green thing come from? Because I subbed in the limit of 1, right? My answer is piecemeal because I always say, I don't have any space on the right, and that's bad. So what I'm going to do, if that's okay with you, I need some space on the right. That's all, because I need to write in a piecemeal fashion, right? So I'll do this. All right. Now, I know the limits are between 1 and 4, right? So this only exists between 1 and 4. So then I'll say anywhere less than 1, it's going to be 0, and anywhere greater than 1, also greater than 4, will be 1. So you got to set the upper and lower bounds as well, right? Because that makes it a complete function. Otherwise, if you don't, I guess a lot of teachers will still give a full marks, but some teachers will be like, well, actually, a function per se, x can be bigger than this. What happens there? And you got to tell it it's 0 if it's less than, and 1 if it's bigger than, right? So hopefully that was okay. For the first question, let's do another one. So from PLC, this question here, they tell you that the contingency, that's a PDF again, right? So once again, total probability rule kicks in. Now, what's this? So it looks like this is piecemeal. It's a third, so it's flat. It's flat initially, and then it's linear, and then 0 thereafter. Okay, interesting. All right, so sketch the PDF. Nice. Median, so find set it equal to 0.5. I think for this graph, actually, there's a bit of a, I'm hoping that the graphs actually help me, but let's see, find the probability. Okay, cool. So sketching this now, if I was to go here, let's go, this is a third, and it's telling me from 0 to, let's say 3 on 2. Maybe I'll go 1's over here, 2's over here. What's that? That's 4.5. Oh, I'm too big. Yeah, so because 9 on 2 is 4.5, right? So maybe I'll go 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Now 1.5 is there, right? So this is from here inclusive. So there to there, 1.5, right? Make that more dotted. Yep. Now on the green one, let's find where it starts and ends, right? So because 3 on 2, by the way, see how they all got equal signs, right? It sort of give away. Normally it wouldn't, but in this case, it literally doesn't matter, because if you sub in 3 on 2, 9 minus 2 times 3 on 2 on 18 should be, I'm hoping it's a third. So let's have a look. 9 minus, that's 3, that's 6 on 18, that's a third, right? Why do I know? Because they both have equal signs, right? Which is normally naughty for a piecemeal graph. They both have the same value, right? So actually, the green linear graph starts off at where this guy ends, and let's see where it ends up. Probably ends at 0, right? Let's have a look. So that's when t equals to 3 on 2. Now what happens when t equals to 9 on 2? Let's go 9 minus 2. Yeah, look at that, equals 0, right? 18 equals 0. So actually, by the time it hits 4.5, goes down to 0 like that. So that's 3 on 2. That's 9 on 2. Perfect. That's my graph, right? And 0 thereafter, right? Well, I don't really need to illustrate that, but yeah, but you can, yeah. So this guy here is y equals to f x or ft. Yeah. Now, part B, find the median. Guys, so basically, there's 2 ways to do this, right? You can use a formula that I did before, but when they give you this graph, and the graphs are nice rectangles and triangles, right? Basically, it's like, where in the graph is it such that the area is 0.5, right? Because that's what I want. Median is basically, if I add up all the y values, right? All the areas where I hit 0.5, that is whatever the x value is, that is my median. So I'm just gonna test, right? And this isn't really a test, I can see it, right? If I did the area of the rectangle here, right? As an illustration. Okay. Now, if it's smaller than 0.5, I'll keep going. If it's bigger than 0.5, I'll wind back to sort of know that my area of 0.5 is part of the rectangle. But if it's too small, then I know the area 0.5 sort of goes into a triangle, right? So using that So part B, yeah, just to test the area of the blue, whatever it is, square rectangle, right? The height is a third. The base is that. Now area is 3/2 base times height, which, surprise, surprise, happens to be exactly 0.5. Now, what does that mean? If that's 0.5, then the X value here is my median, right? That is my median, this guy here. So therefore, median is 3/2. Does that make sense? So let me say it again. If that blue area was smaller than 0.5, I would need to go into the triangle to try to find where it is, right? But if it's bigger than 0.5, I would cut back into the blue rectangle to see where the 0.5 would be, right? By basically, because I know the height, and all I need is a base to target an area of 0.5. Yeah, makes sense, guys. So that one there, pretty straightforward. Oops. Let me rub this off because then I'll do part C just on top. Yeah, part C was that. Find the probability. So part C, find probability that 1 is less than equal to t is equal to 2, right? So basically, this is, once again, this is dealing with area because area is really nice. Now, this one here, if I were to, I delete the blue for now. Yeah. This is asking me, can I please find the area between 1 and 2, right? So I'm not going to use any sort of fancy sort of integration. I'm just going to find the area of that rectangle and the area of that trapezium, right? Quite straightforward. So I know that this guy's going to be, there's a rectangle looking like that, right? Plus, and there's a trapezium looking like that. Yeah, I mean, you can use calculus, right? Absolutely, you can, but why, right? So just to be clear, this guy is a third, and from 1 that's a half, right? This guy here, this is a third. Now I know this is a half down here. This is a trapezium. I have no idea what the height that is. So if I sub 2 into that, right? So let's off to the side here. So when t equals to 2, 9 minus 2 times 2 on 18. What's that, guys? 9 minus 4, that's 5 on 18. Okay. Okay, not pretty, not pretty. 5 on 18. Yeah. Let's see where this takes me. So a bit of space here. The area there would be half times base times height, plus this is a trapezium where the height is at. So it would be h divided by 2 and the 2 other values added, right? And that's just a calculated piece. So let's have a look. So it'd be 1/6, right? Plus now that guy there, if I go 1/3 plus 5 on 18, yeah, times by a quarter, that's 11 on 72. Guys, add that together. Final answer, 23, 22. Is that okay? So look, you can use integration to do this. I didn't, right? You can have a go. Should get the same answer. Yeah, probably between 1 and 2. Yeah, it's another one. This one here. So same deal here. So they give you a PDF. So total probability kicks in for me to find A, right? Classic question, right? Yeah, classic question. What's this function? Wow, okay, not too bad. Linear. Second one, CDF. So after integrate, and once again, remember my limits of 0 and 8. Okay, cool. And integral to range. Yeah, so I need to find both and then take the difference. All right, part A. So once again, it's PDF, guys. Total probability of between 0 and 8 of the function itself. Should go to 1. So take out the A. And to make my integration easier, I'm going to make that come upstairs. -half dx equals to 1. A, now integrate that. So add 1. Oh, can't yet. I need a derivative of that in front and divide by 2, right? So A on 2 now I can use a power rule or reverse chain rule, whatever you want to call it. 9 plus 2x, add 1 to the power, divide by new power equals to 1. Oh, limits of 8 and 0. Yep. Well, not 8. Oh no, 8. Yep. I thought I was finding CDF. That half and that half goes away. So if I sub 8 in, what's that? 16 plus 9, that's 25. Square root minus sub in 0, root 9. It's really nice numbers actually. What's that, guys? A equals 5 minus 3, that's 2. Is it half? 5 minus 3 is 2. Let me just check that. Sure I'm on the right track. Perfect. Very nice. Very nice. Yeah, very nice. Now I don't have space. Not so nice. Maybe down here. Right, so now let's do the CDF better than we did for the setup for the other one. CDF. Remember, it's from 0. Sorry. fx equals 0 to x of, now I've got, so it should be a half square root 9 plus 2t dt. There you go. Good setup. Right, so I've already integrated upstairs, right? Basically is this. Yeah. So where's my integral? It'll be a times that, right? That's my integration. So I'm just going to go there. So I'm just going to go a is a half, so it'll be 1 on 2 square root. So square root. So it'll be 1 on 2, 9 plus 2x power a half. Right, now I still got limits, right? Just, oops, sorry, I should use t now. I should use t, still got limits, yeah? T, and then x and 0. Right. So remember, after I do this, I'm going to do it in piecemeal with the 0 and the 1, yeah? So let's say when I sub in x, obviously that's going to be a half. Now I use square root now. 9 plus 2x, then minus a half. Sub 0 in, root 9, 3. So therefore, I'll factorize a half out, and it'll be root 9 plus 2x minus 3. Quick check, perfect. Oh, I said half, wrote third, very nice. Yeah, so to write that better, right? Oh, I can't fit it, so I'm just going to move this down, then move this out, right? And then put in my piecemeal. Therefore, capital Fx equals to piecemeal, right? So I can do 0 here, 1 here. So this is when 0 between x between 8. X is less than 0, greater than 8. Does that make sense? So always a piecemeal function, right? Whenever it's smaller than the lowest bound, then it's 0. Whenever it's bigger than the highest bound, it's 1. Yeah, can't be, because sum of all probabilities can never be bigger than 1 or smaller than 0. Yeah. All right. Now I'm going to do C over here, right? So I can see the question while I'm doing it. So part C, 3 marks, right? So what I'll do, so I know Q1, right? Yeah, it's basically the integral from 0 to x. Yeah, maybe I'll use a, where the function, right? So it's a half, 1 on, because I found the half, right? 9 plus 2x dx equals to 0.25. Let's do a quarter. Yeah, do a quarter. So I've integrated this, haven't I? The integral of all this, right, is the same as that green highlighted bit over here. So I'm going to pop it in. So a half with limits. Oh no, I'm going to use CDF. I'm going to use CDF, right? Because I already found the constant as well. So instead of using that, I'll use this instead. It's just cleaner, right? Where is it? Down here, this guy. Yeah, just sub it in, right? Sub it in, so it would be a half root 9 plus 2x minus 3. Yeah. sorry, when I say x, it's a now. Yeah, so this is missing. This is missing, right? Equals to a quarter. Yeah, so make a the subject basically. So the 2 comes up. So maybe I'll go. 2 comes up, so it's half plus 3 is 7 on 2. 7 on 2. Let me just check that. Yeah, square both sides. So 9 plus 2a equals 2. 49 on 2. Divide by 9, 2a. What? No, minus 9. Jesus. 49 on 2 minus 9. 31 on 2. Is it? And then divide by that. So 31. Give me a sec. What have I done? I thought I did it right. What's a quarter? So just sub in 2 plus. Okay. I thought I did it right. 31 on 4. Good luck giving me the same answer. Let me just check that. Let me check the math, right? So all I'm saying is sub in that, making that equal to 0.25 times the 2 up. So they're working out is that. So I'm just checking my math. Give me a sec. So what did they do? They times it by 2. So if I was to integrate this, I should get that with the limits of 9 and 0, 7 and 0, I should get that. Oh, yeah. So if I had to do this from scratch, this guy, a, and then sub in a minus 7, 0, which is 3, because it's 0.25. Oh, wait, times it up, half plus the 3 over 7 on 2, square both sides. Yep, 49 on 4, that's why. Yeah, 49 on 4, okay, let's do that again. 49 on 4 minus 9, 30, yeah, okay, there you go. 13 on 8, perfect, better, yeah. That's the, now when I say A, this is Q1. So we do exactly the same calculation. What I'm gonna do, if it's okay with you, I'm gonna move this over. I'm just gonna copy and paste for Q3. So for Q3, we do exactly the same thing, right? And the only thing that's different for Q3, like everything from here onwards, the same, but that's 3/4, right? So I'm just gonna borrow that statement and go, you know, when I say borrow on a PowerPoint, I can essentially just copy this, can't I? How about that? Let's just borrow that and just edit. Yeah, let's do that. So that's a 3. This is not 7, so that's times 2. That's 3 on 2. Well, 3 on 2. 3 on 2 plus 3. 9 on 2. 9 on 2 square that, so it's 81 on 4 minus 9. So this is 81 minus 9 is 45. And then this guy here, 45 on 8, is now my Q3. Guys, does that make sense? And therefore, interquartile range, right? Is that what they're asking me for? Yeah, interquartile range, IQR is equal to Q3 minus Q1. So let's go there. So minus 10 on 8. Let's see. So if I go 45 on 8 minus 13 on 8, sweet 4. That's my final answer. 7 marks. I mean, that actually was a lot of working out, right? But that's how you do it. Yeah. So be careful about the little fractional errors, such as the ones I made. But that's how you do it. So to do the interquartile range, you got 2 choices. You either integrate this again, or if you're smart about it, you just use the cumulative distribution function, which you already found, right? And then just pop, right? Actually pop it into there. And then you sub your numbers into find A. Yeah? Is that cool? Let's do another one. Mode, right? Just to show you the full breadth of questions. Yeah, so maybe I'll let this be the last question. I think you get the point, right? Hopefully that's some good revision for you. This one here, I don't think it's that hard, but we'll see. Now this one here, they give you a function and they go show that it's a PDF. So I need to show that if I integrated that with the limits of 0 to 1, that it equals to 1, right? Pretty easy. And then find the mode. Yeah. So part 1, basically I need to go integral, right, between 0 and 1 of the function minus 6x squared, right? I'm hoping that whatever this is, it gives me 1. Right? So if I integrate that, what do I get? I get 3x squared minus 2x cubed, right? That becomes, so you got to show your teacher the substitution. I mean, I know it's going to equal to 1, right? Because it says show, that's a cube. That's 3 minus 2 minus 0, so that's 1. Therefore, fx is a PDF. Yeah, easy. As easy as that. All right. Now, part 2. Mode. So with the mode, remember, if this is I mean, that's a parabola, right? So 0, that ish. So I know at the turning point, I think the answer is going to be half, right? So let's play the game, right? You can sort of see it already, right? The answer is going to be half, I think. So, but if you had to do it, right, you'd basically go, well, if fx equal to 6x, oops, minus 6x squared, and f dash x equals 6, because the parabola has one turning point, it has to be, sad face has to be max, right? Minus 12x equals 0, because of half, right? Therefore, mode equals 0.5. So I thought I'd show you one with mode, just to give you a bit of comfort. Now, how about I do one more question, right? Skip to the last, because I haven't really done what the expected value and variance. Here it is, Hunter's Hill, very quickly to end this. This is that, find the A that makes, okay, PDF, yeah, cool. So find A, and then expected value, variance, piece of cake. Find A. Find A is PDF. So if it's a PDF, guys, I always write this, if it's PDF, sum of all probabilities between 0 and 1 of this guy, dx. Check the 1. Right. So that's nice. That's not so nice. That's okay. Limit 1, 0 to 1. When I sub 1, now when I sub 0 in, everything zeroizes. I will show the working out though. Yeah. Times A times 1 minus, yeah. I know these are all going to be zeros anyway, but let's go with it. So 1, that all goes away. So really, it's 1 minus 1. Therefore, A is 1. Yeah, is that right? Check. Yes, perfect. Right. But B, if A is 1, yeah, then expected value equals between 0 and 1, yeah, of x, fx, dx, right? Which for our case, I'm just going to multiply each one of these by x. So it'll be x times 2x cubed minus x. Now I found A to be 1 dx. So that's integrating 2x4 minus x squared plus x, right? So let's see what that is. So it's 2x5 on 5 minus x cubed 3 plus 2. Guys, if it's okay with you, I'm just going to skip the zeros. So when I sub 1 in, just be 2/5 minus 1/3 plus half. Now, if I did that on the calculator, think it's 17 on 30. That is expected value. Now, do I have any more vertical space? Not really, so I'm just gonna do this. I'll put part A over here. I'll move part B up here. Zoom in, let's go here. Right, now for variance. I know it's gonna be second moment minus first moment squared. This guy is this guy, so I'll sub that in there later. But for now, this guy, right? It's going to be that 0, 1 x squared times the function, right? Yeah, so let me just do that first and I'll plug in the pink bit later. 0, 1 5 minus x3 plus x squared dx. What's that? x6, so x6, 3, 4, 3. Now, so okay, we use sub 1 in, so just come to the third minus a quarter plus a third. What's that, guys? So, 5 over 12. So this is the blue answer. So therefore, final var would be 5 on 12 minus 17 on 30 squared. Yeah, let's punch in the calc. 17 on 30 squared, 43, 450. Perfect. How's that, guys? So, continuous random variables, many parts, right? You can have a lot of the questions revolve around just simply integrating using total probability to find a constant. Sometimes then they go, can you please define the cumulative frequency, cumulative distribution? And then they either go find the median, find the interquartile range, expected value variance, right? Mode even, median, all of that fits within this framework. Hopefully that's useful. Guys, if you like that, like the video, subscribe to the channel. I'll see you guys at the next one. Cheers, thank you.